Bhaiya. I hope I'm audible.
Yes, you are.
Yeah, okay. So my first question is, was IISERK your first choice among all other IISERs?
It's an interesting question actually. When I was applying, Pune was my first choice because I'm from Mumbai, so Pune is closest to Mumbai. But I wanted to put IISER Kolkata as number 2. But my mom, she wanted me to go to Trivandrum because I'm from Kerala. But I didn't want to go there. I wanted to go to Kolkata because I wanted to study physics, and these were the two oldest institutions, Pune and Kolkata. So I had to put Kolkata as number 3 to make her happy. But it turns out that after the exam, I got Kolkata. So I got my wish, and she wasn't happy about that in the beginning, but then So yes, IISER Kolkata was among the top 2 of my choices.
Okay. So my next question is for our undergraduate students here. So can you share some highlights of your time at IISERK?
Yeah, IISERK was amazing because, of course, it was the first time I was staying away from family. And right after, so in my case, I was also doing all kinds of, I was not sure whether I want to do engineering or science. So I was busy. You probably all know how busy 11th, 12th is. So after that, I got this freedom and then also a great bunch of friends. And it was a very remote place, as you all very well know. It was probably more remote than what you are used to. So it was a completely different experience coming from Mumbai and then staying somewhere where you have to travel like 60 kilometers to reach any sort of city life. So that while that was negative on one end, it was also great because we got to spend a lot of time together. So people were not really going home. So that means evenings you could talk, you could have fun, play games, whatever. But overall, I think there was a strong sense of community among people there, and that really helped making sort of like lifelong friendships.
Again, a question for our undergraduate students. What were your pre-major choices, and did that have an influence on choosing astrophysics as your area of specialization?
Yeah, so for my pre-major, I don't know if we used to call it pre-major or not, but what we had was because I'm not really sure if that's the exact system which is being followed. So in the beginning, I had to study physics, chemistry, mathematics, earth science, and there was also like a computer science course. And then in our second year, we had to choose 3 subjects. So I chose physics, chemistry, mathematics. That wasn't because I didn't like biology. That was just because I had to choose 3, and I had a horrible time with biochemistry. So I thought that no, I don't want to do biology. So I just chose physics, chemistry, maths. Astronomy. I mean, I was from the very beginning interested in astronomy. So there were many more people who were interested in astronomy. But then when you realize that astronomy is not just looking up at the night sky, because that part is very interesting and everybody likes it, but it's more looking at the computer and data analysis. A lot of them change their interests. So in my case, it has that didn't deter me from my interest in the topic as such. So I knew that if I wanted to do astrophysics, I have to take physics and mathematics. So in a way, yes, but I didn't really choose it because it will be perfect for us. I just chose the 3 subjects that I most liked.
Okay. Can you share your most memorable or funny moment or situation during your stay here?
Yeah, there's just so many of them that it's difficult to sort of choose one. But one of the times where I really felt stupid was so this was like in the very beginning, and I didn't know much Bengali. So I was in the canteen with one of my friends, and so in Bengali, like when you leave, when you take leave, you just say Ashchi, and Ashchi is like translated. This guy, he also didn't know Hindi that much, so he translated literally as Aata hu, which is Hindi for I'll come. And then I just thought, me being naive, I just thought that okay, what he meant was that okay, he's going to come back. So he left the canteen, and for the next 20 minutes I was just sitting there because I thought that this guy is going to come back, but he just meant that see you again. So for 20 minutes I felt like okay, what is happening? And then I realized when I talked with some of my friends that yeah, he just meant that he is taking leave. So yeah, I still remember I still remember that incident. He's like a close friend of mine, but I still remember that.
Okay, IISERK has a lot of students from many different places. So, can you share your describe the strength of?
Just a minute, Swati. I would like to interrupt in between a little. You can share some more of similar cases. Like if you want to share, you're free to share.
Oh yeah. It's just choosing like couple of them from a lot of. Like a lot of these experiences is quite difficult, but overall I would just say that like we had, I mean there were cases where so it was like, for example, like first year, and we are all told not to share our VLAN passwords and IISERK passwords and all these things, and it was my first year, and a couple of friends, it was night time, and then somebody just guessed my password, and then one of my friends, because they knew what I liked, what I didn't like, and then one of my friends just said that, oh, it's my sixth sense that this guy has kept the same password in all of his social media and everything, and they got hold of every one of my accounts, and then I had to struggle to get all of them locked. So that was a pretty stressful period for an 18-year-old. Just new to living alone, but then you have all these friends, and they were like, I mean, everybody was doing everything in fun, but it was really stressful at that time. But yeah, but overall, it was a lot of fun.
Okay, so as I was saying, like, IISERK has students from many different places. You are native to Kerala. You're coming from Mumbai. I am myself from Kerala. So, can you share the sense of community among students at IISERK Kolkata and how it eventually influenced your academic and research experiences?
Yeah. So one of the most amazing things about IISERK was that I found people from all different parts of India. And while I am from Mumbai, so I haven't really lived in Kerala that much, but I speak Malayalam, and we had a very big Malayali community at IISERK when I was studying, and it's not just Malayalis speaking with themselves. It was sort of an intermingling between so many different people. You probably know how well Onam is celebrated in IISERK, and not just Onam. It's the Odia feast. It's Saraswati Puja. It's Durga Puja, and all these festivals are sort of. Everybody chips in, joins in, and celebrates it as if it's their own, and that has always helped us, not just among friends within the batch, but also interactions between juniors and seniors, and that extends much more than just IISERK life. Because when you're done with IISERK life, you go out into the real world, but you never know when you need the help of a particular senior or junior. And then, because of these relationships that you have built over all these interactions, they are extremely useful. So, it has played a significant role in my sort of academic path, because I got to know about several of these positions and research avenues from seniors who had gone out to do summer projects, and they suggested how I should apply to different places, and those things definitely help. So I wouldn't be able to do that if I didn't involve myself in any of those activities.
were there any professors or research mentors at IISERK who had a significant impact on your academic and research journey?
Yeah. So I don't know if you have had the good fortune to be taught by Ananda Das Gupta, ADG, because if he has taught you, then I don't have to explain how he is. But our batch was extremely blessed that we had several classes by ADG himself over the 5 years, and the way the breadth and depth of his knowledge has sort of helped us ask difficult questions, and he still manages to answer them. And then we have to go back to our hostels, try to find more difficult questions, ask him, and we were never really able to sort of stump him. But the way he responded to those questions with insight and lucidity, that sort of helped me a lot in my. So when you're a PhD student, you're supposed to teach undergraduates as a TA. So that really helped me. And of course, my master's thesis mentor, Professor Narayan Banerjee, he is one of the best professors I've ever had. And he was patient with whatever stupid things I was doing, and he guided me in such a way that I was able to finish my thesis. His influence. So while whatever I did for my master's thesis is not directly related to what I did during my PhD, it definitely builds a foundation that is sort of invaluable when you go on to do independent research.
Again, did any of these professors have an influence on your career choice?
Yes. So they astrophysics. They both are sort of theoretical physicists. But I realized that while I do like theoretical physics, what I am more excited about is trying to find new objects and new weird astrophysical phenomena. And the best way to do that is to go into observational astronomy, which means you could use telescope time to look at any interesting object you find and try to follow it and see how that fits into the picture. So it's more dynamic, and it's sort of you need more eyes to do that. So I just thought that that's what I liked. But what they influenced me is how to do research more than the exact research topic, and how to do research and how to communicate your research, and also how to behave with students or people who are less experienced than yourself. So that's something not everyone can teach you. So that's an immense influence they had on me.
Okay. I guess a lot of people would like to know the answer to this question. Are you open to collaborating with current faculty or students at IISERK for future research projects or initiatives?
Yes, absolutely. My dream is to have some sort of. So what I work in is called as the transient astrophysical domain, which is time domain astrophysics, where we look at interesting objects that change in matter of they change within our human life. So it's important to look at these new objects with telescopes across the globe, and it is an extremely collaborative field because you want telescopes all across the world so that it is nighttime somewhere all the time. So that means you can look at the object and have interesting results. So it's a dream of mine that someday there'll be a transient group in IISERK Kolkata, and we can. But we are getting there. There are several programs which are starting in India, so I'm very hopeful that in the future there'll be a lot of astrophysics happening from Kolkata.
Okay. How did you particularly apply for PhD, and what made you choose the particular university you are in, or the mentor you're with now, and what were the requirements for pursuing astrophysics?
Yeah. So in the US, so that's where I applied because in the US, one advantage over applying to Europe or some other places is that you get an opportunity to come to the university and then work with a professor, and if you don't like that, you can change to another professor, and that's okay. And also, your project is not 100% defined, so that means you have a little bit more freedom on choosing what you want to do for your PhD. My PhD applications were extremely stressful, as I had expected. I had applied to many places, but I got acceptance only from two universities, and then so I didn't have too much worries about thinking where I should go, because I had two options, and then I chose the one where I wanted to go. So in my case, what was special was, so I was working in gravitational waves, and when I applied for PhD, it was 2016. And if you remember, the first gravitational wave detection happened in 2015. And there was a sudden boom in the sort of applications for gravitational waves PhD. And some of the places where I assumed it were sort of a safe option for me were no longer safe, because there was just too much competition, because suddenly the field became extremely hot. So you cannot really predict which place is really safe for you. But nevertheless, when you apply, the general strategy is that you should have a mixed bag, where you have some ambitious places, some places which you feel like, yes, you can probably get in, then some places where you are more confident. And while all this is said, the most important thing I believe in a PhD is your advisor. So it doesn't matter if you go to Harvard or MIT. If your advisor is not compatible with you, your PhD experience is going to be really, really bad. So so you should always, if you're choosing a place to go to PhD, one sort of tip that I have is that you should look at a place which has multiple different faculties. If say astrophysics is your interest, you should go to a place which has multiple people working on astrophysics, not just one person. Because then if you go there and you are not compatible with this person and you don't want to leave astrophysics, you're sort of stuck. So I would say that your advisor and their research is more important than the prestige of the university.
Okay, this question is more on the technical side. What observational techniques and instruments have you used or are familiar with in your supernova research? Also, can you describe a specific discovery or observation that you've made using these techniques?
Yeah, so supernovae are generally detected by optical telescopes. So you have these large collaborations where there are optical telescopes across the globe, as I was saying. So the goal of having such a geographically separated set of telescopes is that you want it to be night. So it is always night at some place on Earth. So if there's an interesting object in the night sky, you can have these telescopes observe it 24/7. So that means you have continuous data from all these telescopes. So that is something I became familiar with during my PhD, where I got to work with several different telescopes across the world. So we get data from these telescopes, and you reduce this data and try to find out what is interesting about this object. So I can tell you about one interesting discovery we made, which is, so this is a little bit technical, but in the sort of early universe, we don't see much stuff, but recently means in the last 20 years or so, people found that there's a lot of dust which was detected in the early universe, which came as a surprise, because dust is ubiquitous everywhere in the universe, and dust plays a great role in planet formation and thus life. But we don't really know exactly the origin of interstellar dust. But we assume that dust was formed by these stars called as asymptotic giant branch stars. They are AGB stars. But these stars only produce dust when they are really, really old. So that means in the early universe, when these stars were very young, how could they produce dust? So it was a puzzle as to why is there so much dust in the early universe. So a hypothesis was that what if supernovae produce dust? And so by supernovae, we mean massive stars. So let's say to 10 times mass of the sun. When they end their life, in that process, if dust is formed, then maybe we can explain the dust in the early universe, because supernovae can occur within few million years. And in astronomy, million years is nothing. So it's a very small amount of time. So we found that in this interesting source that we used a lot of optical telescopes, we found that there is a dust formation, and because dust has formed, we could see a spectral imprint of this dust, and we found dust in a very rare type of supernova. So that makes this source really, really interesting. So if we find more such cases, that strengthens the hypothesis that supernovae are dust producing and they could explain dust in the early universe. So that's a technicality, but that was a nice discovery.
Again, a technical question. What insights can be gained from studying supernova remnants, and how have you particularly contributed to this field of research?
So supernova remnants are a little bit different from supernovae in the sense that they are related, of course, because supernova remnants is what is left behind after a supernova happens. So if you look at the famous examples of supernovae like Kepler supernova or Tycho supernova, which happened like 400, 500 years ago, if you look at that place with your telescope, you will find extended beautiful features across multiple wavelengths. And these features tell a lot about how the star exploded and how material from the star was distributed in the vicinity. And the distribution of this material is extremely important because this is the birthplace of all heavy metals. And whatever we see around us, iron, calcium, any of those metals were produced from supernova explosions. So it is really important to understand the distribution of nucleosynthesis materials, and supernova remnants are the best way to do it because they stay bright for over 1 million years. And so I worked on a very interesting object called Supernova 1987A. This is important because it is the closest observed supernova in the last 400 years. And it is so close to us that we have been able to observe it consistently since 1987 when it was first detected. And we found that it is entering a new phase of evolution where, so if you think about it, the shock from the supernova sort of goes out, spherically symmetric. It goes out from the site of the explosion. And the farther it goes, the stuff that it heats is from the past. So the farther the shock goes, the farther back in past you are looking at the evolution of the star. So how did the star look 100 years before explosion? How did it look 1,000 years before explosion? And so on and so forth. So you get a complete history of the star by studying supernova remnants. And that's exactly why it is so important to study these rare but extremely interesting objects.
Again, a question for the students here. What advice would you like to give to students at school or undergraduate level who wish to turn their passion for astrophysics into a career option?
Yeah. So the first thing I would say is that you should go do a project in astrophysics because it might not be what you think it is. At least that was true for me and many of my friends, because we just thought that astrophysics means looking at the night sky and identifying objects and being in awe all the time, because that was what we thought. But it involves a lot of different. It's a truly interdisciplinary field where you need to know physics, chemistry, computer science, mathematics, and so on. But it is sort of the gateway to all sciences because it's easiest to inspire a child to look at the night sky and wonder about what are the mysteries of the universe. And once you get interested in science, then you can go into physics, mathematics, chemistry, or whatever. So I would just say that you should do a project, if possible, at IISERK or somewhere else during your summers, because you have like 2-3 months where you can do this. And as an undergrad, you should explore several different topics of research before you choose one particular topic for your PhD. that might be really helpful.
You also mentioned interdisciplinary research now. So IISERK or all other IISERs offer interdisciplinary research options. So how do you think that contributed to you choosing astrophysics?
It did affect a lot, because, as I said, because we had physics, chemistry, and mathematics during our first few years. I got to learn things like spectroscopy from chemistry, which is extremely crucial in the kind of research that I'm doing right now. So you need to have a fundamental understanding of how atoms behave and what are the emission lines that you can expect from hydrogen, from helium, or any of these other atoms. And they provide crucial clues about the astrophysical origin of some observations. So yeah, it definitely, and I don't have to say about physics and mathematics, because astrophysics is just physics and mathematics. So it is, you cannot do astrophysics without physics or mathematics. But the interdisciplinary approach helped me to also use whatever I learned in chemistry in my research. And these days, it's not just chemistry; it's also biology. There's astrobiology, studying organic life on different planets, different exoplanets, or even Mars, or nearby planets, asteroids. So it's an evolving field which has severely benefited from interdisciplinary education.
I believe you've been in the research field for more than 6 years now.
Yes.
So how different has your research experience been from what you thought it might be like when you were an undergraduate student?
Yeah, it's a lot more difficult than whatever I thought. And one thing I realized, which I was also taught by some of my mentors, is that you will not like everything about your research. If you do like it, you are just lying. Nobody likes everything about their research, but you need to like something about your research so much that it keeps you interested. So when you are doing research, some of the activities might seem really boring, but it has to be done, because that's how research is validated, and that's how, for example, peer review is extremely important, because you might think that you've done something really wonderful, but you need to have an independent set of eyes looking at your work and then providing critical feedback. Nobody likes to see their work being criticized, but that is important for the development of science. So that's what one thing I realized is that research is really hard, very difficult, and it takes a lot of time. Whatever time you assume, it's going to probably take 2 times that. So you have to be okay with delayed gratification. So in this world of instant gratification, that's the most difficult part, to do research without immediate results. So I didn't know that, and it's something everybody realizes when they do it. So you listen to this, and then you'll be like, okay, but then you think your case will be different. You do it, and then you realize that no, it's really difficult.
Okay, so
what do you think are some of the most exciting developments or discoveries in astrophysics that have caught your attention lately?
So in transients, which I work in, one of the most interesting discovery has been the electromagnetic counterpart to gravitational waves. There has only been like one confirmed case, but that opens a completely new window into how we do astrophysics. So as you know that the traditional astrophysics is limited to electromagnetic spectrum. But if we can corroborate with the gravitational waves, which has a completely different origin, then we'll be able to learn so much about our universe which we previously couldn't do. Similarly, probably have heard about this latest sort of discovery where they found nanohertz background gravitational waves, which is also extremely surprising to think that we were trying so hard, we worked so hard to find gravitational waves. Turns out that it's all around us all the time. So it's kind of extremely surprising that gravitational waves is going to change how we do astrophysics. So I'm really excited to be in this field where we can have a back and forth between electromagnetic radiation and gravitational waves.
We are the last question of our day. Do you think astrophysics is mostly about data analysis? And if it is, how do you think people stay motivated to work with it?
So one thing is that I have a problem with the perception that data analysis means just doing some mundane or repetitive task. It's not at all that. So data analysis is a very broad term which involves science and which also involves understanding your data. Because one of the fundamental things that you need to remember when you're working with a computer is that a computer is a machine which gives out garbage if you give in garbage. So if you don't know whether your data is garbage or not, you could publish 50 papers with that garbage data and have a stellar career, but it is built on garbage data. So you have to understand whether your data is good or not. And you cannot do that without data analysis. While that being said, data analysis is only one part of astrophysics research. I would say the toughest part of any research, not just astrophysics, is asking the right questions and trying to narrow down what you want to answer. Once you have that question, then you go and request for telescope time. When you get the telescope time and the data, you clean your data to be science level. That is the part of data analysis we are talking about. And then the secondary data analysis is actually trying to do scientific experiments on it. So overall, I would say that it's only one part of a big sort of machine. And even in that part, if you don't are not careful, then your scientific results would be severely impacted. So it's very important to look at data analysis from a positive point of view rather than something as a chore, because that's not how it is. It's as important as thinking about science or thinking about the question.
I would interrupt Swati a little bit. So regarding the thing you mentioned just now, the nanohertz detection of gravitational waves, the technique you really mentioned. So how does that affect the research options or the field where LIGO, all the LIGOs are working on? Like we all know that LIGO India is coming up recently, and they are building up, and India is also like helping out with all the other countries in the LIGO project. So how does that affect the detection of gravitational waves or the significance of detection of the gravitational waves?
Okay, so the kind of gravitational waves that were detected, that is the nanohertz gravitational waves, they cannot be detected with LIGO. But India has played a crucial role in that. If you look at the Indian pulsar timing array, based on the pulsar timing, that's how they figured out that there is an underlying background of gravitational waves by looking at pulsar data for over 15 years. So Indian pulsar timing array is one of the 5 or 6 pulsar timing arrays across the world which presented these results. But that being said, Indian LIGO plays a very important role. This is because it's more like, let's say there's a gravitational wave from somewhere in the sky. The first thing that the pipeline does, the LIGO pipeline does, is to narrow down where it came from in the sky. So they found out that if there's a detector in India, they can reduce the error bar significantly. So that's why they shipped the older LIGO instruments to India, and they are going to be installed in India, and parameter estimation of where the gravitational wave came from is going to be much faster and more accurate. So that's important because of what I said about concurrent electromagnetic and gravitational wave observations. Because if you know where the gravitational wave came from, then you can point your electromagnetic telescopes there and see what's happening. If you don't know where the gravitational wave came from, by the time you look there, it's already gone. So that's why it's important to have fast and accurate prediction, accurate inference of where the gravitational wave came from. And that's where LIGO India comes in, and it helps reduce a lot of those errors.
Yeah, that's it. Swati, you can go ahead.
Yeah, we're done with the questions. Thank you, Vaya, for it was a great time having you here. I'm pretty sure a lot of students gained a lot of insights from your words here today.
Thank you so much. Thank you.
Bye.
Bye.
I hope that we will get to know about you in India, and we get to plan another meet like this in future. We are ready. We are very
Yeah, and you guys are doing a great job, so please continue to do this. Interview more people so there are more opinions, because research is a very individualistic kind of thing while also being collaborative. So the more people you talk to, the better understanding you have of how different people's perspectives on research are. So yeah, keep up the good work.